taking me a couple of trips to see natural rock openings there. Christopher Morris is compiling a lot of these information from the various arch hunters, and he's got a website, kyarches.com, that shows a compilation of most of the rock openings in Kentucky. He's working with Bill Foltz, Randall Miller. I have yet to meet Randall. I met Bill and Christopher about a month ago. I met him at an art show that Todd Fife was having at the Loudon House. I also have not met Mervyn Wood, but he has done a bang-up job collecting arch information in McCreary County. And in the past, Larry Peterson is a geologist out of Frankfort, used to work for the Department of Surface Mining, and Alan and Nancy Dawson also been gone on a few arch trips with them. I'd also like to thank former UK Earth and Environmental Science students Dan Spalding, Stephen Livingood, and Andrew Holtman, who later worked for KGS. They were all, at one time or another, helped me do some field work. So Kentucky, I know Utah has a lot of arches, and I like to consider Kentucky as the other land of arches. Has the most natural arches east of the Mississippi River, and probably second to Utah in the country. Approximately 2,000 locations so far compiled by Christopher Morris. And why so many? And that's because of the jointed cross-bedded sandstones and underlying limestones in the eastern and western coal fields. Also, limestones, natural rock openings occur in limestones in the bluegrass regions and in the poor pennyroyal regions in western Kentucky. I'll start this with I'll try to show as many pictures of rock openings that I can. One of my favorites is Princess Arch, and you see Monty Rivers there for scale. Recently, a few months ago, I attended a webinar sponsored by the Park Service, and it was a webinar how to present your narrative. And I talked about ABT statements, and these are and, but, and therefore. And I thought I'd try my shot at an ABT statement, and it is as follows. Kentucky is considered to have the second most natural rock openings in the United States, and the most of any state east of the Mississippi River. Research pertaining to the formation and classification of natural rock openings exists in neighboring states, Tennessee and Ohio, but no recent comprehensive geologic research exists for natural rock openings in Kentucky. Therefore, this presentation provides information on the distribution, formation, and classification of natural rock openings in Kentucky. Speaking of previous studies in Kentucky, most of these are site-specific. McFarland, 1954, was a publication of the Geology of the National Bridge State Park. Corrigan and Parks wrote a paper in the Kentucky Academy of Science on bridges in southern Christian County, and this is actually on Fort Campbell military base. Kine and Shelby also, and the Kentucky Academy of Science, have produced publications on Mountain Rock in Livingston County, the formation of the Jones-Kinney Natural Bridge, and formation of Apex Natural Arch. So these are site-specific, but nothing comprehensive for the state of Kentucky. Corrigan and Parks wrote a really good document about natural bridges in Tennessee. It's available from the Tennessee Division of Geology. And Tim Snyder wrote a book called Natural Arches and Pillars of Ohio, which is also very informative. So the distribution of rock openings in Kentucky. The gray dots are the data that has been provided to me by Chris Morris. The red dots are the rock openings that I have visited. And so this study includes 334 locations. You can see the distribution in the different physiographic provinces of Kentucky. Most of them occur in the eastern Kentucky coal fields, also in the western Kentucky coal fields. This is the Mammoth Cave area, and this is where Todd and Victor Fife mostly work. But they've also located many other arches in the western part of the state. This is Carter Cave State Park, Martin County. This is the Red River Gorge area. And as we come down here, all of these are in the Daniel Boone National Forest, and some are associated with the state parks. And as we get down here close to the Cumberland Falls State Park, there are no arches within the park, but outside the park in the Daniel Boone National Forest and close to the Big South Fork, there are many arches in this part of Kentucky. And there's a few along the Kentucky River here in the inner bluegrass region. Natural arch, bridge, or rock opening. Could probably spend a lot of time talking about what to call these openings. Cleland, 1910, was the first to write a definition or define what a natural arch or bridge is. Basically, natural bridges span valleys of erosions, while natural arches do not. And there's a good book by Barnes in 1987. He uses the term natural rock opening. And I personally feel that's a better descriptive term to use, although natural arch and natural bridge are ingrained in the literature and our vocabulary. But there are no standardization of geologic terms when it comes to natural arches. This is an excerpt out of Barnes' book, Human Interests Exceed Their Geologic Importance. This is from the Encyclopedia of Geomorphology. So I'm going to go with natural rock openings, and occasionally I'm sure I will say natural arch. The geologic importance, the importance of this work, I think, can provide evidence for the geologic history of the Red River Gorge geological area and other parts of Kentucky. Do these natural rock openings provide evidence of old water levels, whether it be stream or a lake or a river? And how did pre-Illinoisan glaciation 1.3 million years ago affect tributaries to the Kentucky River? It was about this time that the pre-Illinois glaciers rerouted the Kentucky River to its current location, emptying into the Ohio at Carrollton. Before, it used to empty into the Ohio in northern Kentucky. And so how did that affect, if any, arch formation in the Red River Gorge? And we know a lot about the Paleozoic history of the gorge, but how much do we know about the recent geologic history since then? This is also, hopefully, the research can provide some evidence for landscape evolution. Another reason I think this is important is through geoheritage. Natural arches or rock openings are accessible and featured at many state parks and natural areas across the state. And hopefully this will lead to some tourism possibilities and some really poor economic counties that could probably use, that relied probably on old coal money. So I think there's some tourism possibilities for citizens of the state to visit these rock openings. And anthropogenic objects like bridges and buildings, they vibrate. They may vibrate due to the wind, temperature change, time of day, earthquakes. And I recently saw a PhD dissertation defense from a gentleman named Geimer in Utah, where he did research on these natural rock openings that hopefully will assist the design of similar anthropogenic structures like bridges and buildings. So let's first define a natural rock opening. This is from this definition. It's pretty simple. It's from the Natural Arch and Bridge Society. Natural Arch and Bridge Society, since there is no standardization of geologic terms for these openings, have tried to fill in that void. And natural rock opening is a rock exposure that has a hole completely through it, formed by the natural selective removal of rock, leaving a relatively intact frame. And this is a hidden arch in the Red River Gorge. I'll usually have the name of the arch in yellow within the picture, or it may be green up top of the picture. So the Natural Arch and Bridge Society, they have a standards and different definitions working group that met in the early 90s. It consists of geologists, geographers, physicists, and mathematicians, and trying to document the definition and classifying natural arches. And this is you can see this online at naturalarches.org. It's a very well thought out, detailed document, and includes frequently asked questions, talk about the different parts of natural rock openings, how they form, the dimensions, measurements you can make. And so it's a really good source of information. Members of the Arch and Bridge Society are, along with some scientists that I mentioned above, just like getting out and enjoy nature. They maybe have interest in photography. And I went on to, they usually have a arch rally once a year in the fall time. Most of them are out west, but sometimes they'll come out east. But it's an attempt to standardize the terms used for studying natural arches. First, let's briefly talk about the dimensions of rock openings. I'll mention some of these a little bit later on. This is a very simple rock opening, and with a couple of parts to it. It's easy when you get there. There are a lot of different measurements you can make here, but it seems like the one that's most obvious is how big the hole is. And so, we're always interested in, how big the span is. So the span would be the greatest horizontal distance where the opening is smallest. Similarly, the clearance would be the vertical distance between the ground and the top of the bottom of the lintel. And the dip is the width we measure from the drip line to the drip line. When we visit an arch, if you can crawl through the opening or walk through the opening, we call that bagging the arch. If you're able to go through it and then walk on the deck, that's called double bagging the arch. Have to be careful though. Recently in Tennessee, there was someone free climbing twin arches at the Big South Fork, and unfortunately the guy fell. So I don't risk my life to double bag an arch. The conditions for forming a natural rock opening. This is from Snyder, 2009. You gotta have competent rock. And most of these, or all these in Kentucky, will form in sandstone or in limestone. Nothing in siltstone or shale that is long-lived. You got to have relief, something to get the water moving downhill. As you can see here, this is a small little waterfall, and the water, which is an erosive agent, has flowed through this joint that is right here. This is joint bounded. This is joint bounded. Here's another joint coming this way. And so the water is a really important erosive agent in natural rock openings in Kentucky. Like I mentioned, you got to have joints, and it takes time. So when I wrote time down, when I made this slide last week, I thought of the Pink Floyd song. It's been in my head for a week, and hopefully I can give it to you. It's not a bad song to have in your head. Anyway, this slide's over. Thought I had something more to say. Type of rock openings. The one example I just showed you have all been single openings. If two openings are on top of each other, we call that a double arch. If they're side by side, then we call them twin arches. Triple arches, three openings on top of each other, and triplet, three side by side. And any location that has more than three openings, we call complex. Here are examples. Double arch, this is double arch, and it has two openings right here. It's in the Red River Gorge. There's a nice trail that leads to this, and it's a good hike. Another openings in the Red River Gorge is Angel Windows. It's a twin opening, okay? I don't have an example of a triple opening, but I do have one of a triplet opening. I call this the real Trinity Arch. There's an opening here, there's an opening here, and there's an opening there. And then the complex is, this is in Whitley County, called Hollow Rock. There are only two openings in this picture, but there are many more. Sometimes it's hard to get the opening in one opening, a picture of one opening. You're only afforded a few views in Kentucky of taking pictures of natural arches. It's not like Utah, where you can probably get a 360-degree shot of it. And usually in Kentucky, you're going to have a tree in your way. So I think position on the landscape is important when you're looking for arches. They usually occur on narrow ridges. So if you're searching for arches, and these LiDAR maps, hill shaded LiDAR maps are so much better than using a topo map. Usually would look on there, oh, here's a narrow ridge, it's capped by sandstone, what can we find there? And so these LiDAR maps make life a lot easier. Most of them occur on narrow ridges, and you'll see a little bit later on, we talk about the classification, but I'm calling these type of arches ridgetop arches, top of the ridge. That when you look through the opening, you're not seeing a wall of rock or the earth on the other side. You're just seeing the valley behind it. Okay, so that's my definition of a ridgetop arch. This is Star Gap Arch, Amani again for scale. Really beautiful, sweet arch. You can also find natural rock openings along the shoulders and base of cliffs. This is in the Carter Cave State Park. A nice signature here on the hillshade of Fern Bridge. And this occurs, really at the top of the cliff. And you can see the picture of the bridge right here. And so what's really fun is to, get off trail and walk these cliff lines, and you see all kinds of neat stuff. You might see hominy holes, may even see some petroglyphs. So that's where you're going to find your natural arches, along the cliff line or along narrow ridges. And for this position on the landscape, I'm calling this ridge side, because when you look through the opening, you're usually looking at a wall of rock or the earth and not on the other side. And then lastly, we have natural rock openings that occur in the stream valleys. This is a very popular one, nice bridge that goes there of Rock Bridge. Unfortunately, it doesn't have a cool signature like some of the other arches, but this is where Rock Bridge is located using hillshade. So rock openings form through the physical and chemical weathering processes resulting in differential erosion. And the processes involved that create these openings, this is from Corrigan and Parks, include headward erosions of stream valleys, creates a phenomenon called tension dome. And I'll show examples of this in the coming slides. We also have flowing water, widening of joints, which is related to dissolution. And this is water seeping through the joints, through the individual grains, and between the cements and the grains, slowly dissolving the constituents. And this process also includes mechanical freeze-thaw processes. And then we have roof collapse, which mostly occurs in limestones, areas underlain by limestones. Gravity is not included, whereas a rock may fall into a crevice or a big boulder moves and it creates an opening. Those we call false arches. So this is an example of a tension dome, a diagram that was modified from Davis, 1951, and it's in Corrigan and Parks publication. And headward stream growth is blocked by resistant bedrock. And as you have undercutting and of the rock face, you have an arch shaped, and the distribution of the stresses change. So usually you have stresses going down, but then you get a little cave forming and the stresses change, okay? And I'm not that type of geologist or engineering geologist, but at some point, maybe the stresses converge on each other right here, which would hold up the lintel and keep the rocks from falling in on one another. Whoops. Let's go back. So as you can read here, tension domes develops within rocks that overlie caves. And I'll show you some real life examples here. And so this tension dome, the top of it reaches up into the overlying rock layers, and in some cases will penetrate. This is Cow Cave Arch, this is in the Red River Gorge, and this is in the Alt quadrangle. So this is a little bit more east. But you can see here, these openings here are related to this tension dome phenomenon. Another example of headward erosion in the formation of these tension domes would be at Mantle Rock. Steve Greb and Emily Morris and I are creating a story map for a nonprofit organization called Riverlands Alliance. They promote natural areas in Western Kentucky and Western Tennessee. And they saw one of our story maps and they asked if we would mind doing one. And one of the areas that they were interested in was Mantle Rock, and I'd always wanted to go there. So we picked Mantle Rock for our story map. It's currently in review, but Steve Greb created this diagram showing the cliff face being undercut through time, 1, 2, 3, but at the same time, we have fracture widening on the back side of this opening. So they're working together in unison. So we have fracture widening in the back, and at the same time, we have undercutting of the cliff in front of the arch. And so this is the processes that are involved in headward erosion of the stream valley. And this would be part of the tension dome, this area right here. Mantle Rock is the longest span of any opening in Kentucky. It's in the Fluorspar district in Livingston County, and it has a span of 165 feet that I measured out there. You may see some signage that says it's 188 feet or something like that, and that's the measurement from its widest point, not its most narrow. What's really cool when you see these natural rock openings is when you come across some of them that really provide good evidence of how they formed. I think it's not surprising that maybe these rocks fall a little bit over time. But every now and again, the whole core of the rock falls. And I've got a couple examples here. This is Horseshoe Arch in the Red River Gorge. And you can see the outline of the tension dome. This is the core of the rock that's fallen. Now that this is fallen, this is more surface area to erode the rock, but it may take some time, okay? And just a little opening through the side of this fallen down middle part. Another example is similar to that is NABS Arch, again in the Red River Gorge. Again, the whole rock mass is kind of has fallen here. A little small opening there. This is Larry Peterson for scale, getting through that small opening. And so here's an example where not everything has fallen at once. I think that's Matt Crawford, actually. I think that may be Monty, I'm not sure. But this is Lost Camp Arch. It's in the gorge. And what I think is cool here is you can, let me go right here, you can kind of see the outlines of the tension dome forming here. So maybe this is still growing, okay? And a little bit more with fall. But also, there's not really much fall down associated with this for this opening. So that's interesting. Okay, the next process that creates natural rock openings would be flowing water. And if you look at these types of arches, the Natural Arch and Bridge Society would classify this as a pillar arch, okay? And there's not much debris associated with these pillar openings. But what was really cool about this is this structure, this round hole. And here's underneath looking up, okay? And so it seems to me that it would take a lot of energy to create an opening as round as this. And just to me, it just looks like somebody pulled the plug and water came rushing out. Don't know, but it was real interesting structure. And I think it provides evidence that possibly water level, there was water at this level at some point in the gorge's history. More evidence for flowing water creating natural rock openings. Laurel Half Bridge in the Red River Gorge. You can see the stream flowing through this opening. This is at creek level. This is limestone. It's a long, tight, hollow branch. Again, you have a rock opening is in the back here, is where the opening is. And some of the most compelling evidence, I think, for flowing water creating natural arches is in Mammoth Cave area. This is Blue Spring Arch in Edmonson County and Hobbit Hole, also in Edmonson County. This is a stream valley. and we have an opening here, very rounded, very smooth inside, another opening here, another opening here. So it looks like the water came through here and then worked its way and out this way. Similarly, here we have the creek right here, and this opening is right at creek level. So you have a person in the background for scale, and my rock camera in the foreground for scale. And it's kind of hard to believe that water did not create this opening with it being so close. This is also in Edmonson County. This is Buzzard Cave. It's a really cool opening. There is a recumbent fold right here. So soft sediment deformation, which was pretty neat. It has nothing to do with the formation of the arch, but it's a neat, it's a neat feature right here. Here's the recumbent fold. All right. Now, this is inside the arch. Green River is right down here, okay, at the bottom of the hill. And there are rounded pebbles from the Green River inside this opening right here. And so I think this gives us evidence at least the water level was up that high. And if it didn't create the opening, it's kind of hard for me to believe it didn't create the opening. Third way to create natural rock openings is the widening of joints. And this is involves dissolution of the cements of the rock. Now, water is going to seep through the joints, and in between the grains and between the cement, it's just going to go downhill. All right, and it's going to go until it encounters a resistant layer, and so the water very slowly, because these are quartz sandstones, will slowly, but there's also some secondary iron oxides involved in these outcrops. So that's, again, water flowing through the joint. It hits a resistant layer, and over time it will maybe dissolve less resistant or thinner, or beds that are thinner that surround the arch. Freeze thaw is also important in widening the arch over time. It's, like I said, it's a mechanical means, and as water flow rate increases, as the joint widens, that also increases the rate of chemical weathering. Just a quick example of how freeze thaw won't necessarily create the opening, but again, widens the joint. This is in Laurel County. This is a really cool arch. It's kind of hard to get to. I think we had to call down a fallen tree to get to this level. Obviously opening here. There's another opening here going this way. You would think this is a natural arch, and maybe at one time it was, but there's daylight going completely through this fracture, and certainly see the ice and it's flowing through here. So can't help think that one time these gaps weren't there, and it was a little bit more of a better contact, but over time that fracture has, or that joint has widened. And so again, just showing examples of what I think are examples of joint widening. This is tall arch. This is not too far from double arch. You can see these type rock openings are bounded by joints. Okay, there's a joint coming down here. Water seeps in, hits a resistant layer, and over time erodes the rocks above it. Same thing here. Water seeps down through this joint. It's a resistant layer for whatever reason, and then these areas are eroded through. The last type of arch formation that I'm going to talk about today would be roof collapse. And these are areas underlain by limestone. This is in western Kentucky, close to the Tennessee state line. This is Simpson County. And basically, these are sinkholes that penetrate into a cave. So we have an opening here, back there, we have an opening here. This is a sinkhole that's finally gotten more, larger and larger, and then another opening here. More examples in the Red River Gorge. This is Schoolhouse Branch, underlain by limestone. Again, we have the opening here, and then it comes out on this side. Aptly named limestone arch, similar thing. This roof has collapsed, and we have an opening coming out the other side here. So we talked about the distribution, the formation, and finally we'll talk about classifying these rock openings. So the Natural Arch and Bridge Society, their classification is based on these following attributes. Contextual, the surroundings of the arch. Morphologic, how it looks, shape of certain parts, maybe the lintel. The size of various parts, how thick is the lintel, type of rock involved, and anthropomorphic. It's our relationship, the perceived relationship between the opening and people. That's where a lot of people call these bridges, because they can cross something. So this is the classification scheme for the Natural Arch and Bridge Society. And these are the types of arches that they recognize. And I have emboldened the ones that you could use for Kentucky arches, okay? The problem is, and when I first started doing this, I would go out and let's say, and I would try to fit them into these cubby holes, all right? Alcove natural arches are very common in Kentucky. Cavern, shelter, and waterfall natural bridges, along with pillar arches. Those are probably most common using this classification scheme. But I collected 334 sites, and I had a hard time fitting them in there. I almost felt like I had to force them, and I didn't really feel comfortable doing that. So one thing I wanted to do was to just kind of forget what I knew about the NABS classification system. And I was going to take a representative picture of each arch that I have and group them. Okay, and this is my compilation. I ended up using a lot of their terminology, but I also added a couple. Ridge top, fracture plane, side bridge. It's not one that's recognized in the NABS classification, but it was something that 5 or 6 openings I could put in a category because it looks similar. But again, it was kind of subjective, and I wasn't really all that comfortable with it. So I got in contact with Jason and was like, hey, this is what I'm trying to do. And so we looked at some arches, and he was like, well, let's create a classification system based on the processes from which they formed, okay? So the NABS classification system is good for public consumption. They use words that you can understand. You can say alcove, and I think you could, if you didn't know what it meant, you could look it up and show them as the pillar or a buttress. Like I mentioned, for the rock openings in Kentucky, they don't all fit. So Jason and I spent, I don't know, 3 or 4 meetings over the past couple of weeks, creating a flow chart and a classification system based on process and the relationships of the joints to the opening. Are the joints parallel to the opening, or are they at an angle? Okay. So I believe this second classification we're doing on process is good for scientific communication. And you'll see in a minute, the next slide, but the name's a little long and it may be confusing to non-geologists. It's almost like naming a soil, but I've used words that you've probably recognized before. One thing to remember that different processes can result in similar openings as far as the shape is concerned. So this is the flow chart that we created. We just figured this out last week, and I'll walk you through it. I don't know if it really matters for sandstone or lithology, but is the opening, is there a joint involved? Okay. And so we go down the decision tree. Okay, we got a joint. Is that opening or that joint parallel or at an angle to the opening? Well, if it's parallel, we go a little bit further. If it's an angle, is the joint going right through the middle of the opening or at the side of the opening? Is it bounding the opening? And then next level are the erosive agents we just went over: tension dome, flowing water, dissolution, or roof collapse. So, okay, well, it's parallel joint. Based on the opening I see, I think it's tension dome is the erosive agent, and it occurs on a ridge top. And so that gives us the name of a joint parallel tension dome ridge top opening. And so, as I mentioned, that's I think it actually, for scientific purposes, describes the opening and how it formed and where it occurred on the landscape. But we might have to come up with just this for public consumption. One thing I want to make a point here, and that I'm assuming, is this landscape feature, where it occurs, whether it's the top of the ridge, side of the ridge, or in the valley, I'm inferring time. And I'm assuming that the valley arch is younger than the older opening that's on the ridge top. Future work. Let me back up a little bit. I would say probably this is the most popular type of opening you're going to find in the gorge now, that in the ridge side with the tension dome. So this may be the most popular type of opening in Kentucky. Future work today, I've talked about where the arches are, what they are, and how they formed. What's next is why. And there, I think you're talking about the cements and bedding thickness of the sandstones that are surrounding the opening. The opening, I think, is inherent in the rock, and that's why different processes may lead to the same opening. And is it in the cements involved, or is it bedding thickness? Also, the azimuth, or the orientation of the openings, and the lintel. Is there preferred orientation to these rock openings? Is it to the northeast or is it to the northwest? So that's hopefully some future work that we can get into. And then the greatest question is when? When did this all happen? I think I read recently or saw a headline in the news that Eastern Kentucky is archaeologists were doing research in the gorge, and there may be human habitation of the gorge going back 9,000 years. So maybe it's probably older than that, these rock openings, and maybe they're closer to 1 million years old. If the water levels in the tributaries to the Kentucky River were up in relation to pre-Illinois glaciation. But that's just a shot in the dark, and it's a working hypothesis. In conclusion, and start with another one of my favorite arches, the snow arch. Um, Kentucky has a lot of natural rock openings because of jointed sandstones and limestones. The formation of natural rock openings in Kentucky include headward erosion of stream valleys, flowing water, the widening of joints, and roof collapse. It's difficult to categorize all natural rock openings in Kentucky into the NABS system, which in part is based on how it looks. And the classification scheme based on process and the joints to the opening. What we've created in this study are the joints parallel to the opening or perpendicular. And with that, I'll be glad to take any questions you might have. Hello?
Steve?
I have a question, Steve.
Yeah.
This is Matt.
Hey, Matt.
Good talk.
Thank you.
Have you thought about doing any monitoring of these arches? And I'm specifically thinking of perhaps using the KGS drone to monitor movement, geomorphic changes, seasonal or annual changes, things like that.
In the sense that you remember that the PhD on actually the structural health is what that was about, of arches, how they vibrate. I think that would be cool. I would like to get something into that. The drone certainly would help to get to certain arches that are hard to get to, but right now I'm just kind of focusing on getting my classification scheme correct. But I think there certainly are possibilities for drone usage to get to the ones that are hard to get to, but also, as I'm thinking out loud, also to identify fracture patterns that are around the opening. So that may be a good project for that.
Sounds good.
Thank you.
Hey, Steve, this is Cortland. I know that a lot of the pictures that I've seen of your arches, which are very lovely, seem to be in mainly Mississippian limestone and Pennsylvanian sandstone. Is there any preference as to their occurrence in the age of rock? Do they occur down, say, in Ordovician, like around the Kentucky River in Ordovician age limestone as much as they do in Mississippian limestone?
They do occur in Ordovician limestone, and you can see those around the Kentucky River. Okay. I think more of them occur in Mississippian limestones in both eastern and western Kentucky. Okay. But the majority of openings are occurring in the sandstone, and especially ones with these majestic big spans. The sandstones are, or as you can imagine, a little bit longer lived arches. But there are some Ordovician openings in limestones and Ordovician limestones, but there are more in Mississippian.
Okay, thank you.
Steve, this is Steve Greb.
Yes, sir.
I was wondering have you talked to folks in archaeology at all? Because obviously the overhangs and here are big interest to them to see compare lists or see which ones maybe they don't want to advertise that much because they have had archaeological things there.
I have not spoken to them. We've come across certainly some hominy holes and whatnot, but we're not, we want them preserved as well. And so we're not really all that, we're not trying to promote those areas. And really for the survey, I'm promoting arches that you can get to on a trail. Okay. One, I don't want people to get hurt going off trail. I don't want them to get lost. But also, as you mentioned, I don't want them to, destroy archaeological sites. So, but, reaching out to them would probably be a smart thing to do. It's almost 4 o'clock. I got some more arches to look. If you guys want to look at some more, we can. If you had enough, that's cool too. But this is the main point I was trying to make.